Welcome everybody, and hello and welcome to the intermediate Python training course for TDS. So I'd like to start with some introductions because I realize not everybody has met me virtually yet. I am Rachel Street. I'm one of the co-chairs of the Rubin Science Collaboration for Transients and Variable Stars, together with Federica Bianco. So I'm delighted that so many people have been able to participate in this course, and I hope everybody finds it very valuable. So the course is truly international. We have people joining us from 12 countries around the world. Naturally, that also means that we are widely separated in time zones. So I apologize for those of you who are participating at unsociable hours. To help us overcome that challenge, I will be recording many of the workshop sessions, and I'll post those videos to the website for the workshop as promptly as I can throughout the workshop. So if you miss a session, you can catch up asynchronously. You're also welcome to post questions at any time through the Slack channel. That's TVS at Software Training. So please subscribe to that channel if you haven't already. And I encourage you to refer to the workshop website throughout the course, and I'll keep it updated with links to all of the course content. You'll also find there the code of conduct for the workshop, which we have all agreed to. TVS places a strong emphasis on respectful conduct by all attendees at all of our meetings. So if you have any concerns about that throughout the workshop, please reach out to Federica or myself at any time. You'll find our contact details are on the code of conduct in the workshop website. So without further ado, allow me to introduce our instructor, Dr. Alexandra Ninanek from the University of Manchester. Alex, take it away.
Thank you very much, Rachel. I'll just start by sharing my slides to take you through the introduction to what we are going to be doing over the next couple of days. So hi from myself as well, and you're all very welcome to this intermediate Python development course. I am Alex Nenadic, one of your training team for today. I work for the Software Sustainability Institute in the UK. We are a national facility here in the UK for cultivating better research through better software, and I lead the training team in the SSI, and I'm also one of the authors of this course. And I work a lot, or the SSI rather works a lot with the Carpentries training community. You may have heard of the Carpentries, or you might have attended a Carpentries workshop in the past. This is a big international community for teaching researchers foundational coding and data science skills. And we have a lot in common with that community, so that's why we are joining forces with them rather than doing things separately. The SSI itself has different teams and streams of work. We are not just working on training. We work loads of on research software policies. We try to lobby funders, provide research software consultancies, making sure that people who write code in academia, like yourselves, are recognized and rewarded. And we also engage and work with loads of different communities. With me today, I have a few of my fellow SSIers and also a few close collaborators from our research software engineering group in Southampton. So the SSI itself is split between several sites here in the UK. We have a directorate in Edinburgh. I'm based in Manchester, and we have a small team in Oxford, and we have a bigger team in Southampton. So some of the people who I'll be introducing now are working for the SSI, but there is a bigger group of people in Southampton who are our close collaborators, but are not directly working for the Software Sustainability Institute. So I'll start now with a few more introductions to our training team, and I'm going to hand over to each one of them to tell us a bit about themselves. So if we can have Steve first, please.
Hello, everyone. I look forward to helping you over the next week. So yeah, I'm Steve Crouch. I also work for the Software Sustainability Institute, and I lead the Institute's research software team. So as part of the software team, We do a lot of working with researchers to improve their software directly, the practices they use to develop their software, and also how they manage their software outputs and engage with their research communities. And the other thing I do is I'm heavily involved in training as well, working with researchers to sort of upskill them in terms of their computational data management skills. So working with many others, such as Alex and many others, practically everyone I think else on the call, to develop and deliver new training courses.
Thanks very much, Steve. Can we have James next, please?
Everyone, I'm James. I also work for the SSI, but mostly for the research software group at Southampton, where I'm the deputy director. Within the SSI, I do similar sorts of work in Steve's and Alex's teams, a lot with training and software development. But the majority of my work is actually developing software for researchers at Southampton. And with Alex and Steve, I was one of the co-authors of these materials.
Okay, thank you very much, James. Can you have Sam next, please? Oh, we can't hear you, Sam.
Right. Hi, I'm Sam. I'm a senior research software engineer at the University of Southampton, and I work with the SSI occasionally. So I have done some training, materials development, but I mostly work on developing software for local projects at Southampton. So working with researchers, sort of consulting, writing software for them, that kind of thing.
Thank you very much, Sam. And then last but not least, we have Pip, who you might have received many emails from over the past few days. Over to Pip.
Hi, so my name's Pip or Philip Grills. I'm also a research software engineer. I work in Southampton with the Southampton Research Software Group and occasionally with the SSI. I also manage the organisational side of the training. So if anything's going wrong or you need any help with anything, feel free to reach out to me by my email, which you probably have by now, or directly over Slack, and I will do my best to help you out. But it would be up to the others to lead the training, as they are mostly authors of this material.
Thanks very much, Pip. So Rachel's already mentioned that this is the Rubin space, so we are all expected to abide by the Rubin Code of Conduct, which hopefully someone will maybe paste the link into the Slack chat or Zoom chat, but I'm sure you're all familiar with it. We also have the SSI Code of Conduct and the Carpentries Code of Conduct as well. This workshop is not an official Carpentries course. However, it is designed using the Carpentries pedagogical teaching methods, as well as the lesson template, and also the lesson is hosted in the Carpentries Incubator, which is a repository of community developed carpentry style lessons to encourage wider collaboration, improvement, and reuse around lessons. So because of this, we are also required to abide by their code of conduct. However, I had a look, all three code of conducts are very, very similar. And generally, this just means to please be courteous and respectful to each other and treat others as you would like yourself to be treated. If you do believe someone is violating the code of conduct, we have points of contact for this workshop, and that would be Federica and Rachel and myself, and you have our contact details on my slide. Okay, so moving on with the introduction to this workshop and looking a bit into the motivation, what motivated us to do this. I think we will all agree that modern research is impossible without the use of software, starting from some little small thrown together scripts, perhaps some spreadsheets to store your data and do some quick analysis, through to more complex spreadsheets or some millions and millions of lines of code behind some large scale infrastructures. There are really very few areas where software does not play a key role in research. And in many domains as well, from social science to climate analysis, to biomedical science, to particle physics. And also in your own domain, as you're probably fully aware, or you would not be here otherwise, that software includes the software that you write as well. You're the ones who build this software and that makes all of this magic happen. And after all, the software that you write generates results that go into publications and advances the science as well. So what are the goals for this course? We know that research is an increasingly collaborative endeavor that heavily relies on software. So such software must be robust and reliable. This course will teach you some intermediate software engineering skills to help you design more robust software that goes a bit beyond some few thrown together proof of concept scripts that take into account some considerations about the life cycle of your software, writing software for stakeholders, so other people, not just for yourselves, also some thematics, and also applying a process to designing and understanding and building and releasing and maintaining your software over its lifetime. We will try to present you with a set of core best practices that you can adopt within your own software development teams that will help you write the software that is perhaps more robust and reusable and maintainable than what you've been doing so far. However, this core set of skills, we don't claim that this is an all-encompassing set of skills. It's a selected set of tried and tested collaborative development skills that form a firm foundation to help you continue on your learning journey. Why should we care about the software that we write? Here are some statistics from a survey that the Software Sustainability did back in 2014. So this is 8 years ago, and things have probably changed a bit over the past 8 years. We did a big survey of 15 what in the UK are called Russell Group universities. So these are the top research universities in the UK at the time. And we did a survey about their software usage and a bit about the background of that. We had over 400 responses, and the results show us that over 90% of researchers use software in their research, and the software is fundamental to their results, to around 70% of researchers. Also, over half of their time is spent developing code, but worryingly 21% of researchers have no training in software development or software engineering skills. So there is quite a significant proportion of researchers such as yourselves who are developing code. The software you write is important. Traditionally in academia, software is often seen as a necessary but a throwaway artifact in research. This is rapidly changing, and we as the Institute are advocating for making software a prime output and a first-class citizen in research. We also fight for the importance of people who write software and their career paths, as well as the training that they receive. So software that we all write or you write inherently contains value because it produces results. It contains lessons learned, and it also represents the effort that was put inside in it. And for that reason, you need to protect this investment. Once you write your software, it's often difficult to gauge to what extent it might be reused in the future. For example, it would be great if you can use your software for some unrelated projects, maybe some follow-up projects of your own, or maybe some projects of other people, because you might have solved the problem that other people need solving, or also some other projects might have solved or produced something that you can reuse. So it's difficult to say who will use your software in the future, which parts of your software will be used. Sometimes there is only a portion of the software that becomes reusable in the future. And also finally, you should be thinking about not reinventing the wheel because it's waste of resources. So, and thinking about the reproducibility results as well, because there might be people who want to reproduce what you've done from your software and from your publications, and you need to ask yourself whether your software enables them to do that. So the two key questions you should be asking yourself is, can this software that I'm writing be reusable by others, including yourselves a couple of months down the line? Are you yourself able to rerun your software after 6 months or after a year? And then there is a related question: should this software be reusable? If it's just a few lines of a script to quickly do some calculations, perhaps not. Perhaps it should be reusable. But if it's something that you invest loads of time and effort, and it contains many lines of code and many hours of work, then perhaps you should be thinking about how you should make this this software reusable. Which brings us to another question. At which point in time should you have considered how to engineer properly your software? At which point you cross a line between a proof of concept that will never see the light of the day. And sorry, is there a comment or question from someone? No. So you should be thinking, where do you cross the line between something that may not see the light of the day apart from running on your machine, or something that might be of use to others? Ideally, you should be thinking about this before your project starts, but we know it doesn't happen in practice. And failing that, there is always something you can do now to improve the situation. Even if you've not considered planning and engineering your software, it's not too late to start now. So you need to think about how your software project might change, whether there will be follow-up projects that might want to build up on top of your software, whether your research questions might change. So you need to be able to adapt your software project quickly. Perhaps the design of a key algorithm needs changing, and that leads to the change in the implementation, your software implementation. Maybe a mistake was found during data analysis, and then you need to quickly fix a bug in your software. Perhaps you might have other collaborators coming on board your project. You need to be able to include them in your software development. Someone else might want to reproduce your results or to run your software themselves. Are they able to do that without being heavily hand-holded by yourself? Would they be able to do that just from your documentation? Perhaps you might need to integrate your software with another project as part of a bigger collaboration. So for all of these reasons, you should be considering engineering your software as early as possible. Also, sometimes when we think about programming versus engineering, and I'm sure we've all been involved in programming or coding, as we call it, but sometimes use this programming and engineering terms interchangeably. They are not the same thing. The key points of engineering involve the life cycle of your software, the stakeholders and different stakeholders, including users, the team that is working on development, and the whole process of the design and development and maintenance of your project. And also it gives a wider view of development of your software. So we should be considering how we build or engineer our software. The real question is, in terms of writing this, why haven't we, as researchers, been doing this in academia for the last few decades? And the answer to that is complex. Typically, people working on research projects up to now have not really been paid to write software. They are paid to do research, and they're paid to publish papers on the research results. Also, researchers are not really software engineers, and quite naturally, they are not really interested in software engineering. They are simply interested in their own science, and software is just a means to an end for them. Often they've not had the appropriate training for software engineering because they were being trained to become researchers and scientists in their own domains. So this just wasn't part of the curriculum. So we are hoping that this course will take you a bit further along this software engineering path, and maybe fill in some gaps that might help you with your software projects. So who are we targeting this course at? Hopefully that should be yourselves, and you should be able to see yourselves in this. So we are aiming this course at researchers who are developing code, who perhaps have some foundational coding skills that they've gained either by self-learning or perhaps attending a foundational software carpentry or a similar course. They have been coding for 6 months, maybe a year. They know things like the basic Unix style shell, the basics of version control, Python or R basics. Perhaps this might not be the main language that they use, but they are now facing new challenges. Their software projects are becoming more complex. There is more collaborative development of the software, either external or internal. There are more stakeholders being involved. You have more users, more developers as well. There are also higher expectations being placed on the software you're developing. People might be coming with more requests for change, more requirements, and this all might just become too difficult to maintain. So this course is aimed at this group of people, which is hopefully you. And also, once you reach this intermediate level, once you're passed by the foundational stage, there is a bewildering array of technologies, of tools and practices that you can adopt. And sometimes you're lost as where to go next, what to learn next, which one to adopt in your teams. So hopefully, we are going to help you with that. We are going to try and give you a certain subset of skills and best practices that you can decide upon adopting in your team. And this this set of best practices that we included in this course is based not just on the surveys that we've done, but also from our own experience with working on many software development projects. And also working with researchers such as yourselves. So what we found useful and helpful, and yeah, with working with many software projects. Here is a brief outline. So we are going to try and give you some software engineering skills, including how to work together in a team on a software project. And again, we don't claim to give you everything and all possible skills and best practices, but a decent subset of skills and best practices for you to later implement or choose from. The content of the course is split into 4 topics, which we will cover over next 5 days, and we will stick to one section per day. And there will be one extra day where we will try and catch up and help people keep in sync as much as possible. So that's what's going to happen over the next 5 days. In the first section, which is going to be covered today, we will be looking at setting up a development environment for collaboratively working on code. In section 2, which we will cover tomorrow, we will be delving into practices for testing your software. So looking a bit at unit testing, making sure your code is correct, continuous integration to automate running your tests, and also automating other tasks. In section 3, which is slightly longer, we will be looking a bit at a higher level at the process of software design, architecture, models and paradigms, including introduction to object-oriented programming, functional and procedural programming. So we will be looking at the software design as a process. And then at section 4, we are going to be looking at how you can prepare your software for reuse outside of your own little team, and also managing your software over its lifetime, bringing all the skills that we cover over the previous days together and then using them as a team. So you will be working with your fellow learners on this course. So you may be familiar with some of these things already, some of these topics. So hopefully we will manage to refresh your knowledge as well, or maybe teach you something new. Even if you're familiar with something, please bear with us and make sure that you're working through the material anyway, because the later section will sometimes depend on something done in the previous sections. So try to not to skip things. We will make sure we will give introduction to each of these sections on each of the days. So don't worry if all of this now is going a bit over your head. There is quite a lot of information I'm throwing at you at the moment. So we will go through each section introduction over the next few days. Oops, apologies, just going a bit ahead with my slides. So how will this workshop run? The workshop is self-learning, so the course is self-learning. There won't be any live coding by instructors, so you will be individually going through the material. However, we have a number of helpers on hand to support you with this process. So aim to cover one section per day to keep in sync with everyone else. We will put you in a number of breakout rooms to form smaller groups of people. You will have helpers available in your breakout rooms to help with problems or to answer any of questions or to help with some discussions. Initially, exercises, you will be performing them solo and individually. However, there will be more group exercise in later stages where you will be not just being placed in the breakout rooms, but you will be working together on a single software project. Please feel free to ask questions, start discussions with people in your groups, or ask helpers any questions. Also feel free to interrupt me and ask questions at any point. We will also have some shared documents, either for sharing notes, noting down issues and your questions. And I'm going to just give you a link to the folder with these shared documents. If you prefer to ask questions on Slack, please feel free to do so as well, and we will monitor Slack channel. However, if you want to keep your questions to a single document, that might be useful as well, because naturally questions and discussions from Slack will simply disappear from our view. So to have a more permanent view, we can just use these shared notes documents. In terms of day-to-day structure, so you will be with us between 1 and 4:30 UK time, which is UTC +1, and it's going to be wildly different for the rest of the group, I know. We will start each day with a kickoff at 1 o'clock UK time. This is a slightly longer kickoff because we are covering the introduction to the whole workshop, but it will be much shorter over the next few days. Then you will be going into your breakout rooms and then coming back here in the main room the last 15 minutes of the day for some questions and answers as a group discussion, feedback, and a wrap up. Please take breaks when and as you need them. Try to engage with your fellow learners if possible, but also do what works best. Turn off sound if you feel you're being distracted. As I said, we have 5 half days for 4 sections. There will be a catch-up day, which is going to be on Thursday, because our section 3 is slightly longer and people tend not to have enough time to finish it in 1 half day. I'm going to share the link now to our course material as well. So let me just show this for a second on my screen. This is the course website, and here is the schedule. So you have different sections, 4 sections, and each section contains a number of episodes. So you can just start navigating from the introduction to each section. And then, my machine is a bit slow. And then there are these little arrows which will take you to the next episodes of the section. Please make sure you don't go over the next section during any day. So once you hit the following section, you can pause. You can pause there. To navigate through the website, you either come to the home page where you have this overview of all episodes. There is also menu here with all the episodes, so you can always access this menu from any episodes that you're currently at, just to make it easier for you to navigate. Okay, so just to recap, some final notes about working through the material. Makes sure that you start from the episode that contains the actual section introduction, because it is giving a slightly bigger picture of what's covered in a particular section. In terms of exercises, please try to do them on your own. There are solutions provided for each exercises, but do try and make an effort to do things yourselves. Also, please don't skip exercises, because some later material will depend on you going through the previous exercises and your software repository being in a certain state. There are some optional exercises, and they are clearly marked, and you should be able to skip them if you choose to do so, but all other exercises should be completed. Also, the more you do your exercises individually, the more you will provide different solutions to exercises from other people, and this will become more important in later stages, where we will get you to look into each other's solutions and repositories, and then the more variety, obviously, the better. Again, try and cover only one section each day. Please don't zoom ahead. If you fall behind with the section, you can try and finish off a section in your own time before the next session starts, if possible. So as I said, section 3, which is due on Wednesday, is slightly longer. So a catch-up day will be available on Thursday. But for people who have finished section 3, we have some advanced optional topics that they can do on Thursday. Section 4 on Friday is teamwork. So we will try and keep everyone in sync and make sure that you all start the group exercises at the same time. Finally, do ask for help. Don't suffer in silence. Either come to the main room or send us a message in the main room. I believe if you've updated Zoom, you can send messages to the main room from your breakout rooms. Ask us a question on Slack, and we are here to help you. Okay, so I've been talking for a while. What questions do people have about the material or workshop operations or anything else? Please free to unmute yourselves and speak up. Okay,
I have a quick question.
Yes, go ahead, please.
Sorry. Sometimes with some of these courses, it seems like it's going to be a really informative course, which is great to hear. But a few weeks down the line, if I don't use the information, I forget a lot of it. So will the learning materials that we use this week, will they be available to us later on so that we can refer back to it? Because sometimes like code you use in a task doesn't really make sense if you don't have the question itself as well.
Yes, that's a very good point. So the course itself is going to be available online either until the Carpentries GitHub, the Carpentries incubator GitHub crashes, or the end of internet happens, whichever comes sooner. Yes, you can always come back to the material, perhaps redo the exercises or reread the text. There is quite a lot of text to go through, I have to say. It's quite wordy, and sometimes you might miss a sentence if you're quickly glancing through it. Sometimes you might miss a sentence which tells you to do something, and we've had that in the past, and it has happened to ourselves as well. So it tells you to do something, and then you go and start doing the exercise, and then you might get into a difficulty because you didn't read something. So we are here to help you with that. Don't worry if you skip something. We'll make sure that you get back on your feet. And yes, materials will be available online for you to go back to.
Okay, great. Thank you.
No worries at all. Other questions? Okay, so what I'm going to do now is just going to spend another 1 or 2 minutes introducing the material for first day, so section 1, so that you know what you're doing today. And then I'll hand over to Pip to organize you into the breakout rooms, and maybe give you some last minute pointers from his side as well. So what you will be doing is, what's happening in this first section is that we are pretending that you have just joined a team that works on an existing software project. So everyone starts from this same software project. The project is written in Python, and it studies and analyzes an inflammation in a group of patients. This software project is not finished. It contains some bugs and also contains some tests that are failing, and there are also some tests that are missing. So over this course, you will work either individually or with your colleagues to develop more code and add more code to this project and fix these issues. So in this first section, you will familiarize yourself with the project, and you will learn the tools that other members of the team you joined are using. For the purpose of this course, we selected a number of free and open source tools that we believe make a difference. So you will be using command line to run the code, install dependencies for your software project, and set up a virtual environment to isolate your project from other Python projects that you might be working on your machine. We will be using an integrated development environment called PyCharm, which is a rich software development environment for developing, testing, and debugging code, just to make it easier for you to write code, because it contains a very good text editor as well. We will be using Git to version control our code, and we will be using GitHub to share the code with our team. So with these tools, they are certainly not mandated in practice. You will often have a choice of different similar tools. However, for the purpose of this course, we had to make a choice, and we hope that the choice we made and the knowledge that you pick up here is transferable to other similar tools you may use in the future. And this is certainly the case for the command line. So these days, people don't actually have to use the command line as much to run the code. For example, people use their integrated development environment, such as PyCharm, to run and test and debug the code. You can even interact with your version control software as well from an IDE. However, we do insist on using command line in this course, because we believe that the knowledge of and making you comfortable working in command line is a useful skill that can be applied to running code in other languages, and also running other tools, and perhaps accessing some other environments where you only have access through a command line shell. Similarly, you might find that you want to use, or in your teams, you might use Bitbucket instead of GitHub for version control, storing and sharing your code. That's absolutely fine. You might not prefer to use PyCharm as your IDE. You might want to use VS Code or Spider or Jupyter Notebook or some other IDE. That's also fine. We believe that they're sufficiently similar. And that you should be able to switch between them. So remember, tools chosen for this course are used as a vehicle to illustrate certain concepts rather than to teach you the actual tool. And as you get more comfortable with different tools and their alternatives, then you will select the one that is right for you based on your personal preference, or based on what your collaborators and teams are using. So finally, this section will finish with a bit of a tangent. We will look a bit into Python coding conventions to help you write more readable, more well-documented and consistently formatted code. This is to get you to think about sharing your code and what kind of code should you be sharing, and also to start thinking about writing code not just for yourselves, but also for other stakeholders, or for yourselves in a few months down the line when you forgot what your code was meant to do. So with that, I just want to invite for any questions about section 1, and remind you not to go beyond section 1 today, and try not to skip exercises. Okay, so that's all from me. I'm handing over to Pip now for any last tips.
Nothing from me just yet. We will separate you into 4 breakout rooms in just a second, and there'll be one instructor in each of them, something for you to ask questions to directly, or you can ping them back to the main chat where I will make sure I'm watching. But yeah, for now, good luck, and say, don't hesitate to reach out for questions either via the Slack, the Zoom, or in the questions documents.